Miss Parent here, coming at you with a horizontal problem. Here's a common problem. I have a car, it's going around a curve with a radius of 30 meters and the coefficient of friction between the tires and the road is 0.32. What is the maximum speed the car can have to safely navigate this turn? The important thing to know is that this is an unbanked curve. And so when I look at this problem, I've drawn two views, a top view as if I'm looking down like a bird, and a side view as if I was a squirrel in the road before I got squished. And what I'm going to do before I do any math here is I'm going to draw the free body diagrams, because when in doubt, free body diagram it out. So the side view might be the easiest to look at. And I always know that gravity, or the FG, points straight down, while the normal force is going to point straight up. And I know that because this is a horizontal surface, and the normal force is always perpendicular to the surface. Now, the force that's keeping the car moving in the circle is the inward force, and that would be the force of friction. And so I'm going to draw that force of friction towards the center of the circle, because it's a helping force on both of my diagrams. What I also know is that there are no outward forces here. There's nothing pulling the car outward, and so the only force I have helping the circle is friction. So now I'm going to start with my F-net equation. F-net equals ma, and I'm moving in a circle, so that's AC, or centripetal acceleration. And then I can expand. So with F-net, that's my helping forces minus my hindering forces. My helping force would be the one pointed towards the center, so that's the force of friction. And then I have zero forces pointed outward radially, so minus 0 equals m. A is v squared over r. Okay. Now the force of friction, I know that equation is mu times Fn, and that's going to equal m v squared over r. And then Fn, according to my side view, is equal to Fg. And Fg is the force of gravity, which equals mg. So I have mu mg equals m v squared over r. And I'm solving for v, which means I'm going to divide by m, which is going to make m divide out. And then I'm left with ug is equal to v squared over r. So then I would multiply by r on both sides. So I get r u g is equal to v squared, or the final step would be to take the square root. So v is equal to the square root of r mu g, or as I like to say, the square root of rug. And then I'm going to plug some numbers in. So that would be the square root of 30 meters times 0.32 times 9.8. And if I put that into my calculator, I get 30 times 0.32 times 9.8, and then a square root. I get 9.69. Whoops, I'm out of the screen. Equals, V is equal to 9.69 meters per second. And that's your answer.